Let's talk about how to give language models the information that they need in order to help you do what you want them to do. Now we have a data set up here. It's called Louisville Metro Kentucky 311 Service Requests 2013. Now this data set contains about 100,000 rows. It's from Louisville, Kentucky, and every row in this data set corresponds to a 311 request. If you don't know what a 311 request is, it's a number you can call in most cities in the US when there's an issue that the city itself needs to resolve. So if we look in the service name column, we see stuff like stolen garb cart. So I assume that corresponds to a stolen garbage cart. We see damaged garbage carts. So I don't know what's going on with the garbage carts in Louisville, but people call about them a lot in 311. Signage repair. There was an issue with a stop sign or a street sign, something like that. Concerned citizens would call into 311. Then the city would be able to send out whoever they need to send out in order to fix this stuff. Now I'm interested in getting to know this data set a little more. And if we look here, we have latitude and longitude, which means we can definitely plot this stuff on a map, and I want to see what's going on. We also see this thing called council district, which I assume is a way to geographically divide up the city. I imagine there's maybe 25 or 30 of these districts in total, and they're just different parts of the city. So what I want to do is what I have in the instructions over here, and that is create a map that displays each of the 311 requests having to do with sign repair. Color code each point based on its council district. So I want to see all of the signage repair requests, and I want to know what district they're in based on the color of the dot. This output is going to be a map. When I click generate over here and we run, we can actually see this map. And this is definitely confirming my suspicion that council district is a geographical thing, because if we look, all of the points that are of a particular color are kind of grouped together. All these reds over here, I guess, correspond to District 9. And yeah, I know this scale is interesting at best, we'll call it. But regardless, this is still very cool, and it does get the map. We can see that it's the Louisville, Kentucky area, blah, blah, blah. Now, the language model actually needed to really understand this data set in order to generate this graph. Let's think about this for a second. I tell it, create a map. When I was talking to you guys earlier, I said, oh, we have latitude and longitude, so we can create a map. I don't ever mention latitude or longitude here. I just tell it, create a map. And it's able to figure out that based on the fact that I say map, it needs to use the latitude and longitude columns. Next up, I say having to do with sign repair. Now, sign repair, having to do with sign repair is very vague. We were able to see it just with our own eyes when we look over here, and I saw, oh, signage repair under the service underscore name column. I didn't tell it there's this column called service underscore name. And when I say sign repair, I mean capital signage space capital repair. I just said having to do with sign repair, and it was able to infer that this is what I meant. And if we take a look at the Python code, we can see that's exactly what it did. It translated sign repair into signage repair. And then the other thing I said, color coded based on its council district. So council district is definitely a little easier for it, and just for us in general to see that it comes from this council underscore district column. But I didn't use the exact column name. I used a more informal English representation of it. And what I want to talk about is how it was able to do all this stuff just based on the request I gave it here. And what we're going to do is go into ChatGPT, and we are going to ask it the exact same thing. This model, GPT-4o, is actually the same model that was able to generate this graph, or rather generate the code that would generate this graph. So why don't we do something like this? I have a CSV file that contains a row for every 311 request in Kentucky in the year 2013. Write a Python script to satisfy this request. So it's going to go and do its thing. Maybe it'll write a Python script, and maybe it'll be decent. And while it's doing that, I want us to think about, imagine you have a friend. Your friend knows that you're somewhat tech savvy. You can do stuff with data. Maybe you're a data scientist, and your buddy is looking for some help. And your buddy works for the city of Louisville, and they've tasked him with generating this graph. And so your buddy texts you and he says, hey, I need your help. I need you to create a map that displays each of the 311 requests having to do with sign repair. Color code each point based on its council district. Like, imagine your buddy literally just sent you this text with no other information. You said, oh, I have this CSV file. How can I write the code to do this? You'd probably look at him and you'd probably respond, where's the CSV file? I need more information. Where is this file on your system? What am I even supposed to, like I can't even, there's nothing to even start with here. This is kind of a ridiculous request. I would actually be annoyed if I had a buddy that texted me this with so little info. This is a disrespectful thing to do. So hopefully your friends are not texting you ridiculous stuff like this. But the language model is kind of like your friend, but the language model will never tell you no. A good friend will actually tell you no sometimes and will tell you when you're crazy and when you need to think a little bit more. The language model will never tell you that. The language model is your friend in a lot of ways, but it's not a true friend. And the reason is because it's terrified of making you upset. Based on how it's trained, it's supposed to be helpful and always do what the user says. And in this case, instead of telling you outright, why don't you tell me more information about this CSV? I'm not going to be able to generate a Python script unless you give me more info. It says, okay, and it hallucinates a bunch of stuff. And when we say hallucinate, that refers to it making something up. And in this case, it made up that I have a file called Kentucky 311 request whatever CSV. And if we look here, it was not able to translate sign space repair into signage repair. Couldn't do that. That didn't stop it from being confident, of course. It was able to get latitude and longitude. That one is probably because if you're talking about a map, you almost always are talking about latitude and longitude. So being confident in that is a little more reasonable, but still, this is kind of ridiculous. And it would have been much nicer if it just told me, no, I can't do that, but that's not how they work. The reason that over here, we're able to generate the code and have it do all of these things that I've talked about, but we're not able to do it here is exactly the reason that you wouldn't be able to help out your buddy. We don't know what the file looks like. How are we going to do this? It's literally impossible. It's not magic. It's not memorize the entire contents of this file. So we need to tell it. We need to just tell it exactly what the file looks like. And this is, when we're modifying the message here, this is called modifying the context window. And in the context window, sometimes we put in questions or commands. We tell it, write a Python script. That would be a command. We ask it questions. Hey, how do I do this in Python? Hey, what are all the ways I can cook this recipe? We can ask it questions. But you can also put in notes. You can also put in information for the model to use. And in this case, the notes that it desperately needs in order to make a script that's going to work is the contents, or at least a preview of the contents of the file. So let's go over to PyCharm, where I can show you I have the CSV, and I'm only going to paste in, I'm going to say here are the contents of the file, and we are going to now run the script. This is a key missing piece. This has all the information that it's going to need. And now if we look here, yes, it figured this out. Color map, a little more reasonable. It knew also, by the way, if we look, the districts, which are the keys of this map, actually correspond to the 4 values that it saw here. And we see this here. This looks a lot better. Now, this still is a hallucination. Rather, this line is a hallucination because it doesn't know where the file lives. But this is a lot better. And what we're doing here is called modifying the context window. Just kind of a fancy way of saying just giving it the notes, giving it the information that it needs to answer the question. And this is really what you want to do when you have notes. If you have notes, you can help it out so much, and you will reduce the hallucination rate significantly. In fact, something like this is literally impossible if you don't give it the notes. Now, the thing with the context window is it's not infinite. And we could probably paste a lot more data in. Like, I think this will work. So let's do this. And it'll probably work a little better. So now instead of giving it 5 rows, I'm giving it 30. And so this is not a problem for the model. It can handle that. But as you might have guessed, this file is almost 20 megabytes, which is pretty large. If I paste in almost 100,000 rows, it's just not going to be able to handle it. There is a limit to what you can tell it, and you have to keep that in mind. When we talk about the context limit, that's a fancy way of saying the most amount of crap you can paste into ChatGPT. That's more or less what that means. And it makes sense because if you were to paste in this 10 times, it's kind of ridiculous to think that it would actually be able to handle it. Now, the thing with the context window and the thing with these models in general is I'm not asking the model to do any math here. I'm not telling it, hey, which council district has the most signage repairs? Now, you could ask it something like that. And if you're just asking it to count, you might get lucky and it'll be able to do it. But these language models are not good at math. And I would not rely on them to do stuff like averages, crunching numbers, anything like that, would definitely not recommend doing with a language model. They're much better at writing code to do that stuff for you. Something to keep in mind that's very important. Anytime you're asking the LLM to do something, if there is a cheat sheet or notes or anything like that that would increase the chances of the model getting it right, just think again about your buddy texting you. If he were to actually have sent you, if your buddy, instead of just texting you this horrific request, said, oh, I attached the CSV file and here's some extra information and here's what all the columns mean, then sure, maybe it's still annoying that you got to do this for somebody, but at least you have a chance. At least you have a fighting chance.